Hi, this video is on Earth geometry. We're looking at travel problems, in particular ETAs, estimated time of arrival problems. So I'll be talking you through this, and we'll be looking at a question from John Short's Compendium of General Maths. So we're learning to find ETAs, given information about the start point and the destination of a journey, and other information such as the speed that we're travelling at across the globe. What I'm looking for from you, you should be able to, at the end of this video, identify correct formulas using keywords, find journey times given speeds and distances, find standard time zones and time differences, and this is really important, use diagrams to illustrate your work, lay your work out in an easy to read way, and label the work. These are the formulas that we'll be using. This is from the General Maths formula sheet. We'll be using most of these in this question. And this is the question we're going to look at. A jet departs Hobart at 9:30 in the morning, flies east to Christchurch, maintaining a speed of 350 knots, and after a 2-hour stopover, flies to Honolulu, using a Great Circle route. Find its ETA in Honolulu. So the first thing I've written out is the ETA formula, though it is slightly different. This is the ETA formula. ETA is departure time plus travel time plus a standard time difference. Something I've just added in here is the stopover. So often you'll get that in a problem like this, and one of the first things when reading through it was I noticed this. We had a 2-hour stopover, so this has been included here. Now, in order to work this out, we could start by saying, okay, well, our ETA is our departure time. We know that straight away because we're told here that it departs at 9:30 in the morning. So we can put that in straight away. Now our journey time we don't know yet, we're going to have to work that out. Our stopover time, we're told that that's 2 hours. And our time difference we don't know yet, but we can work out. Now that's the thing I'll do first. The time difference is the easiest thing to work out. So what we're going to be having a look at is our starting point, which is Hobart here, and our finishing point, which is Honolulu here. Those are the ones I'm going to be interested in now for the time zones. I want to work out what the time difference is between those two places. So the first thing I'm going to draw is a flat map. So if we just say, well, this is going to be our time distance working out. Sorry, our time difference working out. And if you draw a flat map like that, we have 0 degrees of longitude in the middle, and it's UTC plus 0. Just universal time coordinated in the middle, or universal coordinated time. Hobart is 147 degrees east, which we can mark on there. Now, to work out what that standard time zone is, this is on your formula sheet, see that here. It's UTC plus or minus the longitude east or west divided by 15. So it's 15 because we divide the Earth into 24 equal bands, and 360 degrees divided by 24 hours gives us 15 degrees per hour. So we have 147. This is Hobart. Oops. 147 divided by 15 gives us, well, it should be a little less than 10, 9.8. And we round to the nearest hour, as it says on our formula sheet. So this is going to give us UTC. Now it's going to be plus, because it's east, it's ahead, we're ahead of Greenwich here, so it's UTC plus 10. That's Hobart. Now Honolulu, that's here, it's 157 degrees there, so we have plus 10 there, 157, and that's going to be then 157 divided by 15, which gives us, this will be a little more than 10, 10.46, but you see this still rounds to 10, so it's 10.46, but that's going to be UTC, and it's going to be minus 10. It's going to round to 10 hours, but it's going to be minus there. So if we think about where we're going from and to, we're going from Hobart to Honolulu. could actually fly that way around the Earth, but I'll draw the arrow this way. And we're going from here to there, which means that our starting point, plus 10 hours, and finishing here, minus 10. This is 20 hours behind Hobart. 20 hours behind Hobart. If we're going the other way, Hobart would be 20 hours ahead of Honolulu, going that way. But because we're going this way, it's 20 hours behind. That means our time difference is minus 20. So we can put that straight in here. It's going to be minus 20 hours. Again, 20 hours behind because we're starting here and going backwards that way. Okay, the next thing we need to work out is our journey time. So to work out our journey time, first we need to know how far we've travelled. So we're going to have our first leg, journey 1. Now, journey 1 is from Hobart to Christchurch. Whoops. To Christchurch here. And it says we are flying, this is important, east, which will take that to mean due east because, look, we're at 43 degrees south here, 43 degrees south here. Means that we can travel along a line of latitude due east. And we're told the speed there, which we'll come to in a bit. So this is a due east problem. That means it's going to be a small circle problem. If we have a look back, when we have to choose one of these 4 formulas to work out the distance, first thing we need to know, is it great circle or small circle? And it's small circle because we're going due east. So it's one of these 2 here. Next question is it kilometres or nautical miles? Well, if we have a look, our question says very clearly here 350 knots. So that's giving us a big clue. We're travelling in knots, which is nautical miles per hour. So this is going to be our most appropriate formula. D equals 60 theta cos alpha. So that's what we need to write in next. So D equals 60 theta cos alpha. Now remember, alpha is how far north or south we are. Okay, that's the measure of latitude. So our latitude is 43. You can see this is where we're travelling from Hobart to Christchurch. It's 43. So straight away we can say D equals 60. We don't know what theta is yet. Cos 43. Now to work out how far apart they are, the angular separation between those two, we need that top-down view. So draw a top-down view of the Earth. We have 0 degrees here. We're at Hobart, which is 147 degrees east. So if we put that Hobart there, that is 147. And then we're going round to, where are we? Christchurch, which is 172. I'll put that in a different colour. Hobart, now it's not quite 180, but it's not far off. So all the way around to there is 172. Now we want the angle between them, which is just that smaller one there. So we're going to have the angle will be, theta will be 172 minus 147. Okay, which leaves us with 25. Oops. So that goes in here. That's 25. We can then work out what the distance is. So our final distance is going to be 60 times 25 times cosine of 43. So we get 1097.03, and don't forget what we're measuring in here. This is nautical miles. So 1097.03 nautical miles. Excellent. Okay, that's the first distance. Now we've got another journey, journey 2, which is the second leg, and that goes from Christchurch to Honolulu. So that's the second leg there. Now this one says, you'll see here, using a great circle route. Now we're not travelling due north or due south here. You'll notice we're going from 172 east to 157 west, so we can't just travel straight up and down, which means this great circle route means we need our large angular separation formula. So we need to work out what that angle is, and we're going to use this formula here. So that is that the cosine of the angle of separation between those two places is sine lat p, the latitude of the first place, times sine times the latitude of the second place, lat q, plus we have cosine of the latitude of the first place, cosine of the latitude of the second place, so lat q, times the cosine of the longitudinal difference. Ooh, you can just about make that out. Okay, so we know some of this already, which is quite easy to put in. So cos theta is equal to the latitude of the first place. So we're going from Christchurch, and our latitude is 43. Now it's 43 south, so this is going to go in as a minus 43. North is positive, south is negative. So then it's times by the sine of the latitude of the second place, which is 21 degrees north, so that's going to go in as 21. Plus, then we'll have cosine of the latitude, that's minus 43 again, times cosine of 21. Now we need the longitudinal difference. So again, we want that top-down diagram here. We're going from 172 east, which is there. We're going to 157 degrees west, so it's like that way, 157 degrees west. What we want then is the angle between those two places. That was Christchurch and Honolulu. So the angular separation there is 360 degrees in a circle, minus that 157 and minus that 172, which comes out at, let's just check it, okay, we get 31 degrees there. Okay, so 31 degrees there, it means our longitudinal difference is that. So cos theta is equal to this, so we put that into our calculator. Just start putting that in, sine minus 43 times sine 21 plus cosine of minus 43, cosine of 21, and then it's multiplied by cosine of the long difference, which is 31. And that gives us 0.3408. Now that's good for cos theta. We're expecting it to be between minus 1 and 1, so 0 point something or minus 0 point something. I've got 0.3408 here. I've put dot 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 to indicate that I've not truncated or rounded it yet, and now we need to find the inverse cos of that to find theta. So just inverse cos, you can drag that down, and that gives us 70.06. Okay, so our next thing is we need to work out what that distance is on journey 2. So the theta equals 70.07. We're not quite finished. We need to go and have a look at our great circle formula, and remember that we're working in nautical miles. So we're choosing d equals 60 theta for this part, which is nice and easy, luckily. So we've got this continued up here. D equals 60 theta. So d equals 60 times 70.07, which we'll do in the calculator, and equals, so 4,204.2 nautical miles. Next thing we need to work out is the journey time for journey 1 and 2. So we've travelled, we need to work out what the total distance travelled is, and then work out the time. Speed equals distance over time, that's on your formula sheet down here, which means that time equals distance over speed. 1097.03 plus 4204.2 divided by 350 knots gives us a time of 15.1478 hours. So that's 15 hours and 0.1478 hours. We need to work out what that is in minutes. So 0.1478 times 60 gives 8.868 minutes, or 9 minutes to the nearest minute. So our journey time is 15 hours and 9 minutes. Okay, last bit. Okay, one way to do this is to say my ETA is 9:30 in the morning, plus I've got 15 hours 9 minutes plus 2 hours stopover, so plus 17 hours 9 minutes. Plus 17 hours 9 minutes minus 20 hours is the same as minus 2 hours 51 minutes, which gives us a final ETA of 6:39 AM the same day. Thank you very much for watching. See you next time.